Okay, so this question is from paper 1, question 9. It's actually from the sample paper, I believe from 2014. Now, some students, when they see this, they get a bit nervous because of the sheer volume of words in the question. Generally speaking, the kind of questions you get in the sample papers tend to be a little bit more difficult and a little bit more wordy than what you get in the actual exam. So I wouldn't worry too much about that. I've never seen a question with this many words on it on an actual junior cert exam. But on the other hand, you shouldn't really get put off by the amount of words, because in the end of the day, it's not really that difficult a question. It just requires a little bit of patience and a bit of confidence just to read through it fully and make sure you understand it. So let's have a quick read. A plot consists of a rectangular garden measuring 8 meters by 10 meters, surrounded by a path of constant width, as shown in the diagram. So 8 by 10, and there's your path of constant width. The total area of the plot, garden and path, is 143 meters squared. 3 students, Kevin, Elaine and Tony, have been given the problem of trying to find the width of the path. Each of them is using a different method, but all of them are using x to represent the width of the path. So you can see here, x is the width of the path. Kevin divides the path into 8 pieces. He writes down the area of each piece in terms of x. He then forms an equation by setting the area of the path plus the area of the garden equal to the total area of the plot. First question is, write in terms of x the area of each section in Kevin's diagram below. Okay, we'll just ignore that for a second. When I get a question with so many words in it like this, what I tend to do to make the question more digestible is to underline all the key points. So with the first point I'll underline will be the 8 meters by 10 meters. Then say the second thing would be the area of the plot is 143. We've got 3 students, Kevin, Elaine and Tony. Each of them is using a different method, but all of them are using x to represent the width of the path, so x. Anything else? Kevin divides the path into 8 pieces, so 8 pieces. He writes down the area of each piece in terms of x. He then forms an equation by setting the area of the path plus the area of the garden equal to the total area of the plot. Okay, so it's the area of the path plus the area of the garden equal to the total area of the plot. Okay, so let's go back to the first question now. It says, write down in terms of x the area of each section into Kevin's diagram below. So remember, Kevin, he divided it into 8 pieces, and he worked out an equation by adding the area of the path to the area of the garden. So the first thing is to write in terms of x the area of each section. So there's 8 sections, 1, 2, 3, 4, 5, 6, 7, 8. So we need to get the area of each individual section. Now this one here is easy enough because we know it's a square and this is x, so it's going to be x by x, which is x squared. And as all of these squares are the same, they're all going to be x squared. So we've got 4 already done. Now we've got to do this guy. So that's going to be, it has a length of 8 meters and a width of x. So area is equal to length by width, so 8 times x is 8x. So that means this one is also 8x. Now, likewise here, we're going to work this out by multiplying the length of 10 by x. So that's going to be 10x, and so is this one. Now, one thing some people forget is to work out what the area of this is. And that's simply going to be 8 times 10, the length by the width, 8 times 10. Or 10 times 8. So that's going to be 80. Right, so we've written in terms of x the area of each section in Kevin's diagram below. That's done. Okay, so now that we've filled in all of these, we've answered part A. Let's have a look at part B. Write down and simplify the equation that Kevin should get. Give your answer in the form ax squared plus bx plus c equals 0. So what does that actually mean? Well, first of all, we have to look back at how Kevin works the problem out. He divides the path into 8 pieces. He writes down the area of each piece in terms of x. We've already done that. He then forms an equation by setting the area of the path plus the area of the garden equal to the total area of the plot. So it's the area of the path plus the area of the garden. So the area of the path plus the area of the garden. So we basically have to add all these up, and we have to set it equal to the total area of the plot. Now this is something that people forget when they do this question. All of this has to add up to the area which we're given up here, which is 143. So we can work this out as follows. We have 4 of these guys, 4x squareds, so we write 4x squared. We have 10x plus 10x, which is 20x. We have 8x plus 8x, which is 16x. And then we have 80 in the middle here. So we add them all up, and that should equal to 143. Once we've done that, then we just simply add the like terms, and we also bring this guy over here because we want to end up with the equation looking like this. We want to have a 0 on this side. So let's do that now. So what I've done here, first of all, I've added the 2 x terms to get 36x. Then I've taken the 143 across to get minus 143. Now we're just going to add these guys to get our final equation. So if we add 80 to minus 143, we're going to get minus 63. And now we have our end equation because we can't simplify that anymore. So we end up with 4x squared plus 36x minus 63 equals 0. Now I suspect the reason that people don't put in the 143 here and then put in a 0 instead is because of the way this question was asked. They think I'm not too sure about this, but I think they may think that they're because you want to get your answer like this, that you have to have a 0 on this side, but that's forgetting the fact that you can actually bring the 143 over here to leave you with 0 here. So all this means is that your end answer has to look like this. It has to be, A stands for some number, so it has to be some number beside x squared, 4x squared, some number beside x, 36x, plus some number, minus 63. So this is in the form of this equation here. That's all that they're asking here. Get your end answer to look like this. And the second thing I'd mention about this is whenever you're trying to make an equation like this one here, right? After you've written down all the numbers and the letters, etc., always think about what it actually means. What does all of this mean? It's the area, the total area. So the total area couldn't possibly be equal to 0. So you always have to double check, does this make sense logically, this equation that I'm doing? Okay, so it goes on to say that Elaine writes down the length and width of the plot in terms of x. She multiplies these and sets the answer equal to the total area of the plot. So she has her own method of doing it. She just gets the total length and the total width, multiplies them to get the area of the whole thing. Right. So the part C says, write in terms of x the length and width of the plot in the spaces on Elaine's diagram. So these spaces here. So how would we work out what the width is? Well, we know this is 8 meters. We know this is x. We know this is x. So that's going to be 8 plus 2 times x. Likewise, the length, or the length of the whole thing, will be 10 meters plus the width x plus the width x. So 10 plus 2x. And that answers this question because we've written in terms of x the length and the width of the plot. Now, next question says, write down and simplify the equation that Elaine should get. Give your answer in the form ax squared plus bx plus c equals 0. Well, it says that Elaine writes down the length and width of the plot in terms of x, and then she multiplies these to set the answer, and then sets the answer equal to the total area of the plot. So she's multiplying these and putting them equal to the total area of the plot, which is 143. Again, we have to give our end answer in this form. So we multiply the width times the length to get our area. We're going to do that by expanding out the brackets as follows. So to do this, I prefer to use the split and repeat method, which basically means we split this in two. We first of all multiply the 8 by all of this, and then the 2x by all of this. So 8 times this, and then 2x times all of this. And that gives us as follows. So 8 times 10 gives us 80, 8 times 2x, 16x, 2x by 10, 20x, 2x by 2x, 4x squared. And you can see that's very like what we had exactly like what we had the last time, just reordered. So we can just put this at the start and then add these two guys and leave the 80 at the end. So we get 4x squared plus 36x plus 80 equals 143. Again, we can bring this guy over here and take it from 80, and we end up with the same equation that we had before. And this is what you would expect, as both methods are attempting to get the area of the same thing, so you would have the same equation to represent that. So the next question asks us to solve an equation to find the width of the path. So we could take any of the two equations. Well, they're the same equation anyway, so this is the equation. We've got to solve this to find the width of the path, which is x, remember. So there's lots of different methods you can use for this. I have my own method, especially when you have a number next to the x squared like this, which I'm going to show you now. But you can also use the minus b formula if you're not confident about doing it this way. So the first thing I do is I multiply the first term by the last term, and I use this kind of guideline to help you remember. So 4x squared times minus 63 gives you minus 252x squared. Now it's very important when you're doing this to put the term in the middle, right under the middle term here, and also make sure that you include everything in this, like what is 4x squared by minus 63. Include the minus and include the x squared as well. Next thing I do is I put an a over the middle term and an m over this term. And the idea is to get two terms here that multiply to give me this and then add to give me this. But the first thing you should always ask is, what do I multiply to get a minus? So that's going to be a minus and a plus. Then you should think about the numbers. So what do I multiply to get 252 and add to get 36? So it's going to be a plus and a minus. That means the difference between the two factors of this has to equal this. So it's not too difficult because this is a fairly big number. So I would start off at 1 and 252. Well, the difference between them is too large, so then I would go up to 2. So 2 into 252 goes 126 times. Again, the difference is too large, so maybe 3. I might skip 3 and go on to 4. So 4 into 252, well, 4 into 25 goes 6 times with 1 left over. 4 into 12 goes 3, so 63. So 4 goes into that 63 times. Again, the difference is too big. 4 and 63, the difference is not 36. So maybe let's skip ahead. Let's go up to 6. So 6 into 252, let's work that out. So 6 into 25 goes 4 times with 1 left over. So 6 into 12 goes 2. So we've got 42. So 6 goes into that 42 times. That sounds good because 42 take away 6 gives you 36. So we want plus 36, so we're going to make the bigger one 42. Or plus, we're going to make 42 plus. So, and minus 6. But we also have to remember, when we multiply them, when we multiply these, we have to get x squared as well. So it's going to be an x here and an x here. So all we've really done now is we've changed the plus 36x to minus 6x plus 42x. We've kind of split it into two terms. The rest of the terms we just carry down. So we're going to carry down the 4x squared and the minus 63 equals to 0. Now the good thing about this method is that we've changed this quadratic trinomial into an expression that we can factorize by grouping. So we no longer have to worry about quadratic factorizing. We can just do the rather easier method of factorizing by grouping. So we look for something common here, that would be 2x, and also look for the highest common factor in this pair, and that would be 21, so we'd say plus 21. Now to get this factor here, we simply divide this term into this term, so 2 into 4 goes 2, x into x squared goes x, 2 into minus 6 goes minus 3, and x just cancels into x, so there's nothing here. Likewise, 21 into 42x goes 2x times, and 21 into minus 63 goes minus 3 times. So now you can see these two factors are the same, so we can call them common factors, and we can take them outside of the expression as follows. So 2x minus 3 times what's left over. So if we cancel 2x minus 3 into this, we're left with 2x. And then if we cancel 2x minus 3 into this, we're left with plus 21. Now we split the factors and put them both equal to 0. So 2x minus 3 equals 0, and 2x plus 21 equals 0. That means that 2x is equal to 3, x is equal to 3 divided by 2. And 2x is equal to minus 21, change the sign, and then x is equal to minus 21 over 2. So we got two answers for x, 3 over 2 and 3 over 2 here, and minus 21 over 2. Obviously x relates to the width of the path, so it can't be a negative number. So we simply discount that answer, and we say this one is the correct answer. So part F. Tony does not answer the problem by solving an equation. Instead, he does it by trying out different values for x. Show some calculations that Tony might have used to solve the problem. So he doesn't use equations. He just basically guesses what x might be and see if it works out. So how I would do that is I would look at the diagram here and I would say, look, that's 10, so maybe this is roughly 2. I try 2 out for starters. Okay, so if x is 2, then the length would be 10 plus 2 plus 2, which is 10 plus 4, or 14. So the length is 14. Likewise, the width will be 8 plus 2 plus 2, which is 8 plus 4, which is 12. So from that we conclude that the length is 14, the width is 12, then the area must be the length by the width, which comes to 168, but we know it's 143, so this can't be the right answer. So what you do then is you try a few other calculations in this manner. So for example, we might try letting x equal to 1. So if x is 1, then the length would be 10 plus 1 plus 1, which is 12, and the width would be 8 plus 2, which is 10. So it'll be 12 times 10, which is 120. So you can see after trying this, we've got an area that is too low this time. So obviously x is between 1 and 2, so maybe at this stage you might try x equals 1.5 and then you get your answer. So the question just says, show some calculations that Tony might have used to solve the problem. So you don't necessarily have to complete this from what I can read from this question. You've showed some calculations. You've showed x equals 1, x equals 2. I probably would, just to be sure, I would finish it off by saying let x equals 1.5. So clearly this method is a kind of a long-winded way of doing it. But I suppose if you have pretty good judgment, you can get to the answer reasonably quickly. Having said that, I wouldn't say this is the best method of solving this problem. So the last question asks, which of these three methods do you think is best? Give a reason for your answer. So we've looked at the three different methods, Kevin, Elaine and Tony. We've already said that Tony's method isn't very good. It's too long-winded. I'm not too sure which of Kevin or Elaine's are better. I think you could make arguments for both. So as long as you give a decent reason for your answer, you should be okay here. So what I said was that Elaine's method seems to be the best. It seems to be marginally less calculations involved than in Kevin's method. Tony's method is very long-winded. So Tony clearly isn't a good method, but there isn't much of a difference really between Elaine and Kevin. So as long as you give a reasonable explanation, you should be okay for this question.